Hello, everyone. Today we learn the content is the composition, working principle, and overhaul method of electronically controlled suspension. Mission statement. According to the customer's description, a 2016 Audi A8 sedan has the condition that after the car returns to the garage and the ignition switch is turned off, the air pump still keeps working and the burning smell is smelled. And after a period of time, the air pump stops working and the chassis height is at its lowest state. According to the phenomenon of the failure to develop an electronically controlled suspension cannot adjust the chassis height fault repair program. There are three learning objectives. 1. Familiar with the composition of electrically controlled suspension. 2. Master the working principle of electronically controlled suspension. 3. Master the full diagnosis method of electronically controlled suspension system. We're going to learn today in three parts. 1. Recognition and components of electronically controlled suspension. 2. How electronically controlled suspension works. 3. Troubleshooting electronically controlled suspension systems. Part 1. Recognition and components of electronically controlled suspension. 1. Recognition of electronically controlled suspension. Automotive electronically controlled suspension is a kind of adjustable vehicle suspension. The use of air suspension is easy to realize the body self-leveling adjustment. Self-leveling adjustment mechanism is generally integrated in the suspension system. The point of electronically controlled suspension, the static compression is independent of the load and always remains constant, which can improve driving comfort. Regardless of how much load, can ensure that the rebound and compression of the entire stroke is unchanged. Can also ensure that the corresponding ground clearance. Loading does not need to change the front beam and camber. 2. Components of electronically controlled suspension. The A8's adaptive air suspension system consists of an air supply assembly, front axle air suspension, body acceleration sensor, adaptive air suspension control unit, a front display and maneuvering unit MMI, a combination of instruments, a solenoid valve body with pressure sensors, rear acceleration sensors, rear axle air suspension struts, a pressure accumulator, and a rear axle body level sensor. Control system. The control system is integrated in the MMI. Car button. Direct call-up in priority class 1 on the MMI display. Setup button. Display of status information and adjustments. Control knob activates the adjusted new mode. Indicator light shows low status when using standard chassis. Warning lamp shows very low or very high status. Residual pressure maintaining valve. On each air suspension strut there is a residual pressure holding valve, which is mounted directly on the air connection, and which is used to ensure that a pressure of at least approx 3.5 bar is always maintained in the air suspension. Shock absorber, a double-tube inflatable damper is used, which has an electric continuously adjustable function, and the internal electromagnetic coil is not energized when the damping force is at its maximum. When the damping force is minimized, the electromagnetic coil is energized with a current of about 1,800 milliamperes, and the electromagnetic coil is not energized in the emergency condition. Air supply assembly. Installed at the left front in the engine compartment, it avoids noise in the passenger compartment and also achieves an effective cooling effect, which can extend the compressor's on time, thus improving the quality of the regulation. Shock absorber solenoid valve body includes pressure sensors and valves to control air springs and pressure accumulators. Encapsulated gas springs. The retractable diaphragm box is encased in a fulfillment cylinder. In order to prevent dirt between this cylinder and the retractable membrane box, and at the same time to be able to meet the maximum volume of the luggage compartment, a reservoir connector to the damper is used for additional air supply. Pressure accumulator. The accumulator is made of aluminum with a volume of 5.8 liters and a maximum working pressure of 16 bars. There must be a pressure difference of at least 3 bars between the accumulator and the air spring. Part 2. How electronically controlled suspension works. 1. How does electronically controlled suspension work? Vehicle electronically controlled suspension system mode adjustment. There are two modes of vehicle height state and damping adjustment. Vehicle height status is predetermined by the driver's wheel and vehicle speed. Damping adjustment is determined by the driver's wheel, road surface characteristics, vehicle speed, load, and current driving status. The OTA8 is available in two chassis, a standard chassis and a sport chassis. To dot standard chassis, the following programs can be selected manually or automatically in the standard chassis. Automatic mode. The chassis sinks by 25 mm after 30 seconds at speeds above 120 km/h. Sinking the chassis improves aerodynamics and reduces fuel consumption. Comfort mode. The chassis height is the same as in automatic mode, but the damping is weaker at lower speeds, so the comfort is better than in automatic mode. Dynamic mode. Compared to the automatic mode, the chassis sinks by 20 mm and automatically adjusts to the damping curve of the sport mode, which sinks by a further 5 mm after 30 seconds at speeds above 120 km/h. Lift mode. The chassis is lifted by 25 mm compared to the automatic mode, with comfort as the main focus. 3. Sport chassis. Auto mode. The standard level of the bodywork corresponds to the standard chassis dynamic mode, starting at 120 km/h for 30 seconds and then dropping by 5 mm. Dynamic mode. The height of the vehicle is lowered by 5 mm after 30 seconds from 120 km/h, as in the auto mode of the sporty chassis. Comfort mode. Body leveling is the same as in the sporty chassis auto mode, with lower damping than in auto mode in the low speed range. There is no automatic highway body lowering. Elevation mode. The horizontal height of the body is raised by 25 mm in comparison to the sporty chassis auto mode, which is adjusted in favor of the sporty model. Part 3. Troubleshooting electronically controlled suspension systems. 1. Vehicle tilt for taking. When the car starts to accelerate, the load on the front and rear axles will change. The indicator S, M, F should be lit, indicating that the stiffness and height of the suspension belongs to a strong level. Otherwise, there will be a backward failure. That is, the car sinks. The car lifted in front of the front, affecting the comfort of the ride. Check the speed sensor circuit, i.e., the circuit from the SPD terminal of the suspension electronic control unit to the speed sensor ground for normal operation. If the circuit is normal, use a multimeter to conduct the circuit between the SPD terminal and the GND terminal for times, with the voltage varying between 0 and 6 volts. If abnormal, the speed sensor is defective and needs to be replaced. 2. Diagnosis of vehicle sway faults. When the car is traveling at a speed of 40 km/h and suddenly turns, no matter the suspension control mode selector switch is in the position of norm or sport, all the indicator lights S, M, F should light up, indicating that the suspension stiffness and height are at the strong level. Otherwise, there will be side tilt and head bobbing faults, affecting stability and ride comfort. Check that the connecting wires between the steering sensor and the suspension electronic control unit are normal. If the wiring is normal, turn on the ignition switch and check that the voltage between the VS and GND terminals in the suspension electronic control unit should be 3.5 to 4 V. If the voltage between VS and GND is abnormal, it indicates that the suspension electronic control unit is defective and should be repaired or replaced. While slowly turning the steering wheel, check the voltage between the SS1 terminal and the GND terminal and the voltage between the SS2 terminal and the GND terminal. The two voltages should vary repeatedly between 5 and 0 volts. If the voltage between SS1, GND and GND, SS2 is abnormal, the steering sensor is defective and should be repaired or replaced. 3. Troubleshooting of high-speed loss of control of automobiles. When the vehicle accelerates gradually from 100 km/h to 120 km/h, and the suspension control mode selector switch is in the norm position, and the suspension damping force is changed to the medium level, the indicator lamp says NM should light up, but the F lamp will not. Otherwise, check whether the circuit of the speed sensor is normal. The checking method is the same as that in the vehicle tilt fork check above. If it is normal, it indicates that the suspension electronic control unit is defective. That's all for this lesson. Goodbye.